this video is about a particular math topic called the discriminant. So this is a part of the quadratic formula. The video before this had to do with the quadratic formula. And so a very important part of the quadratic formula is this part that we call the discriminant. And this is just the part of the quadratic formula that's underneath the square root sign or radical sign, b squared minus 4ac. So you're probably already having to memorize the quadratic formula for your class, and so it's not any extra to memorize the discriminant, which I misspelled, by the way. Discriminant. My bad. It's not any more difficult to have this memorized. You just have to remember which part of it is important. And what the discriminant allows us to do is it allows us to figure out how many solutions a quadratic equation has without actually having to find them. If you have just done a section of homework on the quadratic formula and using that to solve quadratic equations, then you already know that some of those problems can be really long and frustrating and difficult. Some of them aren't so bad, but even those take some time. So the idea would be that maybe we don't actually need to know what the solutions are, or at least not at first. Maybe we just need to know what kind of or how many solutions we have. So our steps to use the discriminant to figure out how many solutions there are is that step one, which is an optional step, write the equation with everything on one side. It may be that they already are all on one side. Step two, we want to identify what a, b, and c are based on what's in front of x squared, what's in front of x, and what's the number left over, just like we do with the quadratic formula and just like we do with the vertex formula. And once we know what a, b, and c are, we plug those numbers into b squared minus 4ac, and we find out what that number is, paying very close attention to whether or not the minus 4ac part of that ends up being plus or minus, because that's going to make a huge difference potentially on what the number is we get. So because it's just b squared minus 4ac, we should get a number, and then step 3 here shows us what that number means. Because if b squared minus 4ac, right here, if that is greater than 0, in other words, if it's a positive number, then our equation is the normal case for our quadratic equations where we have two real solutions. If we solve it and we get that it equals 0, the equation has one real solution. If we get that it's less than 0, then the equation has no real solutions because instead they're imaginary solutions. If you're in Algebra 1, which is what this video is designed for, then that's all we care about, is that there's no real solutions. We're not worried about what the possible imaginary solutions are. If you're in Algebra 2, then that's a little different, but still for the discriminant at least, all we care about is that our solutions aren't real. So the way to help you remember this is, even though the discriminant doesn't have the square root, basically the square root will help us. Like if we get a positive number like 22 and we have to square root it, remember that in front of that is a plus and minus sign. So we're getting two answers. We're getting a positive answer and a negative answer. There's more to it than just that part, but that's the part of the quadratic formula causing us to get two answers. As opposed to if we end up having to square root 0, the square root of 0 is just 0. Positive and negative 0 is the same thing. It's only 0, and so that gives us one answer. And then on the final case, it would be like we were getting a negative number, like say maybe negative 5. Well, I can't take the square root of a negative number and get a real answer. And so that would mean that there are no real answers. Now I'm using the word answer here because in some ways that may be easier for us to think about, but the appropriate way to say it is what's actually written here first, saying that there's solutions or that there are no solutions. So let's do some examples so that we can see how this works. Especially if you've already done a section on the quadratic formula, this should seem quite a bit easier. So it's already in standard form. Everything's on the left side. We want to identify A, B, and C, and plug them into the discriminant. So b squared minus 4ac. And we want to figure out what this is. Remember that b gets plugged in to the squared and it makes the negative go away. Negative 5 times negative 5 is 25. The negative in the middle and the negative here at the end cancel each other out, so that's plus. And then 4 times 4 times 9 is 144. So that those add together and give you 169. It doesn't matter really what that number is that we end up with. All we care about is this positive, is it 0, or is it negative? And since it's positive, then that means that we have 2 solutions. It actually, in the instructions here, tells us what words to use. So we could use the word real in there as well, or we can just say 2 solutions. So that's our answer. So that was pretty easy. Let's look at another one. Basically, spoiler alert, we'll look at one of each case. So the most important thing here is making sure that you're paying attention to negatives and positives and adding or subtracting the way you're supposed to. So 6 squared minus 4ac. So 36. There's 3 negatives, so that's negative overall. 4 times 3 is 12. 12 times 3 is 36. 36 minus 36 is 0. And so when our discriminant is 0, there is only one solution. So these instructions don't say to actually find the discriminant. I mean, that's what we're doing to get this. But if instructions specify that they want you to find the discriminant, then you absolutely have this as part of your answer. If not, then if they just ask us about the solutions, then technically we wouldn't have to go all the way to finding 0. Once we know it's 0 in our head, then we could just say how many solutions there are. So keep that in mind. It's always important to look at the directions and see what it's actually asking you to do. Final one, process of elimination. We could figure out what this will end up being, but let's see it through anyway. B squared, so 8 squared minus 4ac, so that's 64. I'm going to do 4 and 3 and get 12 and then times by 9 because that's part of my multiplication table, so I know what that is. And then when I subtract, I get negative 44. Even if you subtract that wrong, and get the wrong number, hopefully you're like, oh, well, I know it's negative. So that means that there are no real solutions because we would be taking the square root of a negative number, and there are no real square roots of negative numbers. They're imaginary, just like, some of your friends might be. I know, that might be a thing. So one question to ask maybe is, why would we want to know how many solutions there are and why would we need to know that information but not need to know what they actually are? And there's 2 main reasons that I can think of, at least, that I wanted to share with you. One is that sometimes we just want to know if our equation has an answer, and that's what the discriminant will tell us, because maybe it's actually something that would be really difficult to solve, and so we don't want to go through the effort of solving it if there's not actually an answer when we do. So it lets us know if our equation even has an answer. And so to me, I'm thinking about some of my higher level math classes that the equation might be super duper complicated, but is still designed so that you can use the discriminant and figure out what kind and how many solutions there are, and that in itself actually tells you a whole lot about the problem that's set up without you actually having to know or needing to know what the actual solutions are. The other thing is it actually tells us something about our graph. It tells us how many x-intercepts our graph has. That is not Okay, there we go. Intercepts. That was bad too. Our graph has. And that's what this next section says. Graphically, two real solutions means two x-intercepts. Because our solutions to an equation, when we graph the equation, our solutions are where the graph is going through the x-axis, which is the x-intercepts. So if we should be getting two real solutions, then we know that our graph should go through the x-axis twice. If we're getting one real solution, it means that there is one x-intercept. And so one x-intercept, if you think about it, means that our graph touches and goes back up, or if it's going down, it touches someplace, but it doesn't actually go through. And then no real solutions means that there are no x-intercepts. And so it would hover above or hover below our x-axis. So that means that we could do a problem like the following. It says use the related equation to find the number of x-intercepts of the graph of the function has. I feel like there's a word messed up somewhere in there, but hey. Then match the function with its graph. So in other words, instead of actually graphing these three equations by finding the vertex and using a table of values, what we can do is find the discriminant, figure out how many solutions it has, and then match that up with the x-intercepts. So on this first one, a is negative 1/2, b is negative 2, and c is 0. So we're going to do negative 2 squared minus 4 times negative 1/2 times 0. This part becomes 0, so we just have 4. That means there are two real solutions. Which of these three graphs shows two real solutions? In other words, which one has two x-intercepts? Which would be B. So the first equation matches up with B. We didn't have to find the vertex. We didn't have to make a table of values. We were able to just match up which one was the correct one. So let's do that with this one. So b squared minus 4ac, that's 64 minus 64, which is 0. So 0 means there's only one x-intercept, so it's touching the x-axis, which is what c is doing. And so by process of elimination, C, this last one has to be a. If we do go ahead and find the discriminant, which on a quiz or a test is a good idea, so that you can double check your other problems. Anytime you're matching, you always want to check that even if you use process of elimination, that the last thing that you picked actually makes sense. This is 64 minus 72, which gives us negative 8. So yeah, there are no solutions. There's no real solutions. And look, A does not go through the x-axis. It comes close, but close is not good enough. So our matchup is A. So that's how we would use the discriminant, why we would use it, how we use it, all of that jazz.